Good morning, students. In this today's video of Basic Mechanical Engineering, Unit number 1, Introduction, Lecture number 2, we will see regarding some of the topics like prime mover, the types of prime mover, and basic concept of force, pressure, work, and power. In lecture number 1, we have seen introduction to the subject, the entire syllabus of the subject, what are the course outcome of the subject, and what are the topics in different chapters. In today's video we will cover all these all these topics, and you will come to know what is prime mover, how many types of prime movers are there, and what is the basic concept of force, pressure, work, and power. Friends, all these points or all these words are not new to you. As far as my knowledge is concerned, you all have already gone through these all words. Even you are aware of the word force, pressure, work, power, prime movers. So let us see all this one by one in this today's video. Prime mover. What is a prime mover? A prime mover is defined as a device which converts energy from natural source into mechanical energy or a useful work, that is shaft power. Prime mover which moves is termed as prime mover. The name itself says you the meaning of prime mover. For example, wind turbine, steam turbine, water turbine, IC engine. In one more example we can add, that is electric motor. So these are the prime movers. Now once again, if we see the definition, converts means it converts, a device which converts energy from natural source. So definitely whatever the input is given to all these devices, that is natural form, and it is converted to mechanical energy. For example, wind turbine utilize wind, steam turbine utilize steam, water turbine utilize water, and IC engine utilize the chemical energy or fuel, you can say. So all these energies are naturally obtained. In IC engine you can see sometimes coal also is used, which converts water into steam, and that steam is utilized to operate the IC engine. So different types of source of natural energy is supplied to this device, and this device converts that natural source of energy into some mechanical energy or some useful work, or that is some shaft power. For example, let us take electric motor also. Electric motor, electric supply is given to it, and we get some rotation, that is a mechanical energy on the shaft. Now if we connect any gear or pulley on that motor, it converts or it drives some other component. For example, a blender or a mixture in our kitchen, it is an example of a motor is connected and there is one cutter attached to it, so it will crush the material whatever it is. So these are the examples of, you can say, prime mover. Again, wind turbine, you can see here, wind turbine is an example of, or the steam turbine, this they are the example of prime movers. The IC engine, they are also the example of, you can say, prime mover, that it converts the natural source of energy into some external source or mechanical power output. So the shaft connected to the crankshaft, here we'll get the output energy. The locomotives, these locomotives are also termed as prime movers. So in short, I can say prime movers are the device which converts natural energy into mechanical energy and drives the other components. Now source of energy used by the prime movers, that is thermal energy and non-thermal energy. There are two types of prime movers which utilize thermal energy and non-thermal energy as a natural source. So if we see in thermal energy, the first one is fuel, second is nuclear energy, third is geothermal energy, fourth is bioenergy, fifth is direct solar energy. So friends, you all are aware with these points, or fuel which is obtained from either you can say as petrol, diesel, kerosene, nuclear energy which is again obtained from the some nuclear uh, reactions, geothermal energy which is obtained through natural source, bioenergy either it is a biodiesel or something like that, whatever the energy is there, and main the direct solar energy that is through sun. So these are the thermal energy or the natural source which is utilized by the prime mover to convert that natural source energy into some mechanical output. And non-thermal energy, it means the natural energy used utilized by the prime mover but which are not thermal, means there is no relation of heat in that case. So hydel, tidal and wind energy. So these are the three different types of uh, non-thermal energy which are utilized for the natural source, means which are utilized as a natural source in the prime mover. Now let us see what is force. It is push or pull acting on a body which changes or tends to change the state of rest of uniform or uniform motion of the body. It means you can see here it is a push or pull acting on a body. For example, here you can see in the animated this is the body, a box, and a person is pushing. The other action can be pull. So now when it is applying some action on the body and body is changing its position from rest to motion or motion to rest or some uniform motion. So it's force. As per the Newton's second law of motion, force is directly proportional to the acceleration. So the formula if we see, F is equal to m into A. Now one more example I will give you. Suppose a dining table is there at your home and if you are pushing it, so now if you want to calculate what is the force that I have applied in moving the dining table, then you can easily take the mass of the dining table and the acceleration which you gained when you are moving it, जो acceleration आपने gain किया है, if you are able to calculate both this, if you multiply, you will get the force which you have applied for the means to move the dining table. In SI unit, the unit of mass is kg and the unit of acceleration is meter per second square and unit of force is Newton. So when mass is equal to 1 kg and acceleration is 1 meter per second square, then force is equal to 1 unit. It is a unit force required, unit force applied. अगर कोई भी 1 kg मास हम लेते हैं और उसका एक्सीलरेशन जो है 1 मीटर पर सेकेंड स्क्वायर है, तो इट इज टर्म्ड एज द यूनिट फोर्स, मीन्स 1 न्यूटन फोर्स इज अप्लाइड ऑन दैट बॉडी फॉर moving it. So 1 Newton is defined as when unit mass is given, when unit mass is a given unit. Acceleration, then the force produced is 1 Newton. It means when the unit of mass is means 1 kg mass and acceleration is 1 meter per second square, then we can say the force applied it is equal to 1 newton. The force produced is equal to 1 newton. So many examples are there, friend. When you are pulling or pushing a box in the system, or when you are moving it from one place to another place, the force is said to be done. The next is pressure. It is the force exerted by fluid or liquid gas on the unit area, and it is a property of the fluid. Pressure is the property of fluid, and you can say pressure is equal to force upon area, that is meter square. We all know what is the unit of area. It is a meter square or centimeter square or square, but here we are taking it as a meter square. So you can see here what is the pressure. So if you see this video, this animated portion, here you can see some force is applied on a unit area with the piston, and that some air is generated, and that pressure is created, and that pressure in terms of air, this elaborates the balloon. So this is how the pressure is generated. The unit of pressure is known as Pascal or Newton per meter square. Friends, it's very important. आप सबको ये चीज़ बहुत ही ध्यान से याद भी रखना है. The unit of pressure either Pascal or Newton per meter square. 1 Pascal is equal to 1 Newton per meter square. Work is said to be done when force moves the object through a distance in, you can say, direction of force. Hence work is equal to force into distance moved into direction of force. For example, when I am applying a force to some object, let us take the example of the dining table. I am applying some force to that dining table, and dining table is moving. I am able to move that table by 1 meter. So if I know what is the force I have applied, and I also know how much distance I have managed to travel that dining table, so from that I can say the work is to be done, or work is done there. So when a force is applied to some object, and if object moves from its original location in the direction of force, it is very important that it should be moved in the direction of the force. When it moves in the direction of the force, it is said that work has been done. So for example, you can see here a pulley is there, a weight is there. Now some force is being, you can see this is being lifting. When force is being applied here in this direction, the distance traveled by the some weight, that is in this direction. So the product of this, we can say the work has already been done. So you can see here, when some force is being applied, this object is moving in some direction, and the work is said to be done. So the unit of work is Newton meter or joule. So this is how the work is calculated. Now let us see regarding the power. Power is defined as a rate of doing work or work done per unit time. For example, mathematically if we see, power is equal to force into distance per unit time. Now let me explain you how we can say a power means. A physically fit person is lifting the load of 10 kg and moving that weight from zero location to say 5 meter within 5 seconds, and some physically unfit person is lifting that 10 kg weight, same kg of weight, and traveling 5 meter and takes 10 minutes, 10 seconds, sorry. So we can say the physically fit person is having, or he has applied more power to do the work, while that person has applied less power, or has less power to do the work. So force into distance by unit time. Here, for identifying the power, this parameter is very important: work done per unit time. So you can see here, when we are pulling this 12 newton of force by 5 meter, how much time is required in order to, so the time decides. If time is less, power more; if time is more, power is less. So work done in a unit time defines the power. The unit of power is joule per second. In SI unit, joule per second is also called as watt. Watt is again you can unit of energy or power, you can say. So uh, watt is very small unit. So another larger unit are megawatt or kilowatt. At our home, whatever the electricity comes, that also we calculate in kilowatt. So it is a termed another unit of a power. So I hope uh, the definition of power is clear to you. Once again, let us see. Power is defined as a rate of doing work or work done per unit time. So thank you friends for watching this video. I also request you all to subscribe our channel SSIT.GANDHINAGAR. Thank you. Thank you very much.